This video will concentrate on normality. Now, the normality of a substance in a solution is equal to the number of equivalents of the substance in 1 liter of the solution. So the definition of normality is the number of equivalents of solute per liter of solution. Now let's look at an example problem. Calculate the normality of a calcium hydroxide solution containing 6.32 grams of calcium hydroxide in 5.85 liters of solution. Well, let's begin on the next page looking at how to solve this problem. The first thing that must occur is to calculate the number of equivalents of calcium hydroxide in 6.32 grams of calcium hydroxide. Now, to solve this, we will take the molecular weight of calcium hydroxide and divide it by 2. The 2 is due to the presence of 2 hydroxide ions. So the mass of calcium hydroxide from the periodic table is 74.09. We divide that by 2 since 2 hydroxides are present, and we get 37.05. Now this will be our equivalent mass. We will take our mass stated in the problem as 6.32 grams. We will divide it by our equivalent mass of calcium hydroxide. This will give us the number of equivalents as 0.171. So in the example, we calculated that 6.32 grams of calcium hydroxide had 0.171 equivalents of calcium hydroxide. Do remember that normality is equivalents per liter. Our original problem gave us 5.85 liters for our solution. So to calculate the normality, we take our equivalents, we divide it by our liters of solution stated in our problem, and we would have a normality of 0.0292. The solution is said to be 0.0292 normal. The N stands for the noun normality or the adjective normal. Here we have an example problem that asks us to determine the number of equivalents needed to make 1.5 liters of a 3 normal solution of HCl. Now do remember that normality is equivalents per liter. If we take our 1.5 liters stated in our problem, we multiply that times the 3 normality, which is equivalents per liter. Liters will cancel out, and we would have 4.5 equivalents of HCl. In this example problem, we are asked to determine the normality of a solution of 1 mole of H2SO4 that is dissolved in 1 liter of solution. We have our 1 mole of H2SO4. Now remember that normality will end up being equivalents per liter. Our 1 mole solution had 2 hydrogens. So we had 2 equivalents on top and 1 mole on bottom. Our problem states that we have a 1 liter solution. We multiply that times 1 liter. Moles will cancel out, and we will be in equivalents per liter, which is normality. So our answer would be 2. Here we have an example problem that will require 3 steps to solve. How many milliliters of a 1.5 normal H2SO4 solution would be required to prepare 500 milliliters of 1.2 normal solution of H2SO4? Now, to solve this problem, the first thing we need to do is we need to convert our milliliters to liters. The second thing we must do is to convert liters to equivalents and then convert the equivalents to liters. So as we begin looking at our solution, we take our 500 milliliters, we convert that to liters, we get 0.5 liters. Next, we will take our 0.5 liters, we will multiply that times the 1.2 normal solution, which is equivalents per liters. This allows liters to cancel out, and we now have 0.6 equivalents of H2SO4. We can take the 0.6 equivalents of H2SO4 and now convert this to liters. From our problem, we have 1.5 normal solution. So 1 liter of H2SO4 would have 1.5 equivalents of H2SO4. Equivalents would cancel out. Our mathematical answer would be 0.4 liters or 400 milliliters. Our final example problem is as followed. What volume of 0.75 normal phosphoric acid would be required to prepare 2.5 liters of a 0.2 molar phosphoric acid solution? Now we have 2.5 liters of phosphoric acid at 0.2 molarity. We will first convert and calculate our equivalents. We take our 2.5 liters of phosphoric acid from our problem, we multiply it times our 0.2 molarity. We do this because molarity is the same as moles per liters. This allows liters to cancel out, and we are now in units of moles. We know that 1 mole of H3PO4 would have 3 equivalents due to the 3 hydrogens present. So we can multiply 3 equivalents over 1 liter. This allows our liters to be present, but our moles will cancel out. Therefore, we would have 1.5 equivalents. We take our 1.5 equivalents and we need to convert from equivalents to liters. Now, we have 0.75 normality. So 1 liter would have 0.75 equivalents. Equivalents cancels, and we would now be in liters. Our mathematics would show that we would have an answer of 2 liters.